tonight our speaker is Neel. So I'm super excited to be able to introduce him. He works for eBay and has been working here for like 7 years. And he's created the departments of science data, big data science. So, and he's done so many fabulous things. I'm so excited to be able to introduce him.
Switch. There's still plenty of seats up here in the front if people want to sit down. Too bright. So long may I speak? Hello, yes. Okay, thanks everyone for coming. I've been with eBay for 7 years, as Trisha said. This is my actually third ACM talk. So if you're attending the third talk, I think you've seen everything that you've seen. How many of you went to my previous talk? I'm going to ask this question. Anyway, thanks everyone for coming. So I'm going to talk about some of the cool stuff that we're doing in the research labs and kind of generally what we are doing with big data at eBay. There must have been other people from eBay who talked about our data and what we can do with this data. So my perspective of that story. So, this is my favorite quote from Sherlock Holmes. There's a capital mistake in theorizing for honest data. Anybody who's got a degree in computer science knows we all like to give our theory first before we look at data, and we try to prove that our theory is right without looking at the data. And that's changing. Especially if you're a fresh graduate looking for a job in the industry, first question you want to interview is a student, you want to ask is, have you looked at data before you say, can you improve it by 10%? So a lot of the story I'm going to tell you today are going to be related to data, how data can make your stuff simple and actually implementable, and you don't actually look for complex theory. We're going to just give you a little bit of an overview of big data. A lot of people already know that. This is from the IBM Big Data Source. Over 2.5 exabytes of data, about 2,000 petabytes of data is generated pretty much daily with all the various devices we have. And 90% of all the data has been created in the last couple of years, and this comes from sensors and climate data and social media data and GPS cell phone data, video data, and transaction data like eBay. Right? So all of this, there's an explosion pretty much anywhere you see with the social, local, social and mobile devices, social applications and mobile devices. And plus, to process this data, we also see a huge decrease in the cost of hardware as well as the software that can process them. So that's what makes it all of us. And if I was doing a PhD today, if I got a PhD back in '96, I was doing writing compilers for supercomputers, which probably were which cost over $15 million, but had the processing power smaller than what I have in my hand here. And all of my data came from natural physicists, which I didn't understand or tail off. But at the same time, it seemed cool, like we're working with oceanographers or simulating the universe, etc. But now, when I can work with data, I really understand it. It's a lot more exciting. So I'm really jealous of students who are graduating today and can do this processing in their workstation.
Excuse me, can you keep the mic closer because we're not able to hear you properly?
I can hear myself. Is that better? Worse.
Yeah, it needs to be closer.
Maybe it's, who cannot hear?
It's, we can hear, but it's on the quiet side. If you could also speak up a little bit, that would be good.
When he turns his head also.
When I turn my head, you can't hear me. I won't turn my head.
Okay.
Okay, is that better?
Yeah.
Try not to turn my head. So, it's hard. You can't turn my whole body.
Yep.
So this is a graph of different kinds of data coming. Okay, Brian's fixed it. No, it's almost a coin here. The interesting thing about this data is if you look at traditional data like US population, the way it's growing, or the way the telephone lines are growing, the older data is growing much slower, and the data that's younger, the newer, which is like the Facebook data or the mobile phone data, is growing at a much faster rate than this older data is growing. So in some sense, you've got new sources of data that are becoming much bigger than the older sources that we had before. And this is another example of how data is growing, looking at the goals, how internet users are growing like crazy. And again, if you look at, if you want to process all of this data, computing is getting cheaper and cheaper. This is a compression of the transistors you see, but the cost of storage and memory is significantly dropping. So all it tells you is that you can process all of this data pretty well in a controlled way because everything else is getting cheaper, even though the data is growing. And that's why we're in these exciting times. So how does that story translate to eBay? So I'm going to talk about eBay, and whenever I talk about eBay, I always have my first slide. So if you have seen the talk before, you've seen the slide before, and I asked the question, this was the first piece of data that eBay ever produced, which was the first transaction ever happened on eBay. Anybody who doesn't know the story? One, two. Quite a few people. So this was and Peter was setting up the eBay website, which is called Auction Web then. He was setting this auction site over the weekend, and he wanted to list something, and he had this laser pointer, which he used to play with this cat. He was pointing at the wall and draw circles, and he used to jump around, and it stopped working. So I said, well, let me try to fix it, and he could fix it, and listed it on the side, and said, let me see if somebody would buy it. There's an auction listed at 99 cents, and then he watched what happened after that, and he saw people bidding on this thing, and bidding, and eventually it sold. Because everybody knows without looking at the internet how much it sold for. Any guesses?
$2.
$2?
$10.99.
$10.99? That's the highest answer I've got so far. But I like the $10.99 answer. I don't know why. Anybody else who's not on eBay? Five is usually the answer I get. So I don't know why. So the answer is 1483. So he contacted the buyer and he said, well, I told that this is broken and it doesn't work, and if I fix it, you know what you're buying. And the guy said, yes, I know exactly, because I'm not told to use this pointer. So that's when we realized this one man's flash is another man's computer, and then that's the history. I'm going to have a job, I can get a mortgage, and people on my team have jobs, and Brian Johnson has a job. Okay, so it's a little bit of statistics on eBay, how much data gets generated. This data might be a little bit old because we've had a lot of growth over the last few years. So, about $22,100 worth of goods sold every second on an average day. A vehicle sells every 1.6 minutes. A power and accessory sells every 2 seconds. A diamond jewelry sells every 68 seconds. Parachute sells every 7 seconds. And a trading card sells every 5 seconds. And if you talk to the mobile team, they'll tell you a Ferrari sells every 2 hours or something like that. I don't know the exact statistics, but a lot is happening on the site. So this is the amount of data we're generating for the site. For the data junkies, if you want to look at this data, we have probably 10 million is the low end. It's more like 20 million items are listed every day. At any point of time, over 400 million items, products are live on the site. At any point of time, over 100 million users are active. Over 300 million queries get issued every day. On the other hand, 4 out of 5 items are listed as one of a kind, so they're not products that you can just go to Walmart or Target and buy. And these products are listed over 50,000 categories, and it's got everything from dispensers to iPhones. We get about 2 billion page views a day. We have about 9 terabytes of data we generate. Having said all this, most buyers buy in 1 or 2 categories, and most sellers sell in 1 or 2 categories. So we have this huge parts to data that you see. So all of these data pairs of buyers and revenue, or buyers and products, or buyers in category, or sellers in categories, and sellers in revenue contribution. We all have nice power law distribution. Very few people contribute for a lot of stuff. A lot of people contribute for few each one, and all of them adds up to a lot. So that's kind of the graph that you see.
Will you take a question?
Sorry?
Will you take a question now?
Sure.
So of that dollars per second figure, how much shipping does that generate?
How much shipping?
Can you repeat that question for the audience?
So, if I understand you right, for every item sold, how much shipping does
For dollar amount.
per dollar amount? I won't be able to answer that. I don't even know if I can give out that answer. But one of the things that has happened over the years is more and more items have sold through free shipping. So you won't, it's not a fair comparison. It's not a fair number to generate. And you will also find, if you find fewer of these things, especially in collectibles, you may find a $50 item with a $200 shipping, and buyers internalize some of that cost very well. So I don't know the exact answer for that, unless some of the eBay people know. Do we ever $8 shipping cost per dollar? We don't really do that. It's very hard to do. We can calculate it, but I think a lot of items sell through free shipping.
That's a third-party shipper.
Oh, sorry?
That's a third-party shipper. eBay doesn't own the shipping.
No, we don't own the shipping company. So as a seller will say, hey, whatever the shipping, I absorb it, it's in the cost, and you as a buyer will say, well, either I can buy a phone for $200 with $50 shipping, or I can buy a phone for $250 and free shipping. And that's actually a fascinating story that I'm going to tell you about how much do buyers internalize shipping costs. We'll come back to that. Please ask your question. Any other questions? So, and then we talk about mobile commerce here. We expect the target to be about $730 billion of mobile commerce, and in 5 years we expect handheld devices, which is smartphones, to account for about 30% of the retail. That's kind of the thing. So from eBay, I want to go to research. So what do we do with research? I've got a variety of teams in eBay Research Labs here at eBay. We work on all these areas of research, and there's a common theme that connects all of these things. So we work on search, of course. Search is one of the most important aspects of our system, and machine learning and text mining, as you would expect, as we have all of this data. Computer vision is a newer group. I'm going to give you examples from computer vision a little bit as we have more and more kinds of devices. People are taking pictures of stuff and they're uploading them. Economics is another new department, but anybody saw the recent press about eBay economists talking about paid search? Yeah, people here. There's one person on the back, didn't work for Google too. So we can talk about that later. And HCI is also a new department, but a lot of the stuff is basically the approach we take is all of these groups look at large amounts of data. And the kind of data we have, so we've got user data, we've got behavioral data, product data, query, search data, transaction data, feedback data, image, message, crawl data, real-time data. And this is kind of the data that we process at scale. And one of the things in the labs I tell any new employees that they come on Monday or Friday, they have to have access to all of this data if they want to work on this thing. So we get interns in the summer, and by the time they come in on Monday or some week, by Friday, they have Hadoop jobs which process hundreds of millions of queries. or hundreds of millions of listings, and typically there is a student who's got the best paper award at CIR or KDD and says, well, I know I have a scalable algorithm. Mine can work for a graph of 50,000 by 50,000. And then you say, no, okay, let's start there. And then look at these graphs. So there's another way to look at these people. We've got people know the story of the elephant and the six people, blindfolded people, which is basically our researchers. So whether it's vision or machine learning or IR or search or economics or HTML or graphics, all of these guys are looking at the same kind of data, but looking at it from different dimensions, drawing different conclusions. And this is kind of how we perceive research in the lab, which is everybody's data-driven, but they are pursuing their own interests of research. Okay. And so, I mean, we've seen this is from Kate Roberts' article a few years ago. Basically, when you have so much amount of data, and one of the very nice, concise conclusions from the article is that you have simple algorithms and throw big data algorithms, throw away the existing models, and as new models emerge, just start with some theories and developing new theories. And this is kind of what we do over and over again. So we don't start with complicated algorithms, we start with as simple as possible. We get a thorough look at the data before we go to anything complex, and scale to an extent where we can actually do a lot. And so first thing when we started research at the scale, one thing it required us was to build a very nice platform that all researchers can access the data in an integrated platform. So we got all of this. So we built an internal code name is Mobius, but basically what it contains is all of eBay's data over at the bottom, and then that's Hadoop was from the top. And we provide various levels of API, starting from low-level data access API to kind of Java API here, and there's query languages, there are Eclipse plugins here, and then there are application layers with different jobs. So for example, if you're a business guy and you're just interested in the visualization or the dashboards, and you can just access this. If you're a researcher, you would probably access at a lower level, and if you're an application developer, maybe you would go at this level. So in some sense, everybody has got this common access to data. And we built these beautiful abstractions where you don't even have to know that you're running MapReduce jobs. You're just running jobs that are abstracted in your language. And I mean, that's a talk in itself. I can point you to publications related to that if you want to. We did open source part of this system as well, which is called Open Mobius. Is that right? Yeah. Open Mobius. That's available from GitHub there, where you can download and play with it. And the nice thing about the system is that you can, it's a schema agnostic, which means you can throw any kind of data at it, and you can process the data at scale. Yes?
Any of those data are anonymous and publicly available?
No, so we don't publicize data. So we don't get these questions as often as we used to get. We don't publicize the data, but what we have open source is a mechanism to process large-scale data. So for example, if you have a website, if you have user logs on the website, which is tracked in some kind of a structured form, you can use the system to process that data. So that's part that you open source. And it's actually what you open source is the Java API. And a lot of this other stuff is still in Java. It takes a lot of open source stuff, as you can. So, let's go over this. And the philosophy behind the team that built Mobius, that also came from the team, was that pretty much everybody in the company has to be data-driven. Whether you're in product management, whether you're in analytics, or engineering, or business, or quality assurance, or research, everybody has to be data-driven. So one of the things about providing data access at different levels is that if you're a business guy, you're just interested in looking at graphs. If you're an engineer, you would write code. If you're a data analytics guy, you probably run SQL kind of queries. So we need to provide you access, but at the same time, all of you have to be data-driven because engineers have to know what impact their product has on the usage, and they need to be data-driven for that as well. So we kind of look at an organization also as a elephant in this experiment. Okay. So with that, I'm going to give you 3 examples of the projects, very successful projects we've done in the labs, and many of them have made it to the field, either the field of research or product. So the first area is search. Nish from my team is in the back. He drives a lot of this work. So any questions, just point at him. So, one of the things, this is from an economist actually, said, talks about data to confess to anything. And that's pretty much what these guys did to make the systems I'm going to describe work. Most of the time, 95% of the time, I mean, those of you who are data miners and machine learning people, one thing I have observed over the years is that 95% of the time goes in cutting the data, cleaning the data, looking at it, and 5% doing the other ones. If you're spending it the other way around, you're doing something really wrong. And you'll see the examples of what we did over here. So, one of the, if you've used eBay before, you'll see eBay is a fairly complex place to search for stuff. And our search engine, before Brian will tell you, it's fairly complex to provide a search engine that satisfies everything. Because we've got documents, we've got products, actually items, they're not products, and we've got sellers, we've got trust, we've got price, we've got shipping cost, we've got new, used, so many combinations of stuff for which we have to show relevant items to the query. And I'm going to show you some of the examples of what we become looking for on the site. And it's matching user intent to these products is really a challenge. So I'll give you one example. For example, building a spell checker. So traditionally, if you look at spell checkers, they were dictionary based. They were rule-based spell checkers. Unfortunately, most of the terms that you will see on our website are all e-commerce terms. There is no dictionary for e-commerce, or at least the terms that people are searching for. And so, you could use that outputs of any business. They don't really scale very well. So, but one thing we do have is you've got very creative users, which are advanced users, right? So, a few years ago, you would read articles about people who take advantage of spelling errors on eBay and buy those items and fix them and then resell them back at a higher price, right? So that was the story. The story is about this guy in Los Alamos who bought a $5 camera, bought a $5 camera and sold it for $1,000, and quite often we do that. In fact, the first time we fixed our spell checker, potential buyers were upset with us. They said, "Well, you're crazy because you're killing the business here." Right? So we can mine our advanced users' behaviors, which is their queries and the session usage analysis on this, and see how many ways this could be spelled, because these guys know exactly how others are making spelling errors on the site, because they spend hours figuring out. So for example, for this word, Swarovski, which is this crystal brand company, there are 63 different spellings, and we don't have a dictionary of these spelling errors. But at the same time, these people have incentives, right? Because they are making a living off of correcting the spellings on the site. So why not mine their data and then provide a nice correction for spelling the spells, right? So if you trust me to do the all spelling additions for Swarovski, that either sellers make a mistake or buyers make a mistake. And we don't really care, we just need to understand, right? So nice thing about it, if you do thorough analysis of data is you can get answers for free. You don't have to know English. Like Brian used to say, Britney Spears is spelling for everybody. Maybe that should be the spelling. You don't need to know right spelling for Britney Spears. So here's another example. So people come to the site. One of the things that happens on the site is, sometimes you have very vague queries like this. It says Guinness, and you don't know what they are looking for. So quite often you have to suggest spellings to them like Guinness. So here you see below the query suggestions, which is Guinness watch, Guinness glass, Guinness mirror. So you ask the user, what are you looking for? Because otherwise you've got 10,000 results and you really don't have a good set of answers. So you want to provide navigation support or assistance to users to say, hey, did you mean one of these things? And I'm going to briefly describe how we build this system. So if you go to Google, there will be query suggestions. If you go to LinkedIn, actually LinkedIn pretty much copied our implementation just on paper. They have query suggestions. And it allows users to better broaden or narrow their searches and optimize their buying experience, right? So here again, here we take advantage of the click trace. So here's an example of one user who comes in and looks for helicopter rotation spare parts and he wants cheap. And then he corrects, so this is query number 1, then followed that by helicopter rotation replacement part. And then that followed by helicopter rotation spare propeller. And then he says, well, I give up, he leaves the site, he doesn't get what he wants. Here's another smart user, is an advanced user, he comes in, pretty much starts with the same query, helicopter rotation spare parts cheap, then he says helicopter rotation, something hits him and he says, well, helicopter rotation blades. And then he views 2 items and he purchases. Now, when we do that scale, if we can match this guy, with this guy's request, this is kind of this, what I call Robin Hood approach. Take from rich people and give to poor people. So here's a smart guy who's figured out, so we can mine all this data at large scale, and we know that this is a correction for this, and when this guy comes and hits this query here, we can suggest this as a correction query, and then we can help them have that user find the item they're looking for. So that's kind of the what we undertook. And the first step there is basically, it's kind of like washing before eating. When you get the data at the scale, if you're not careful, our data is written with bots, written with a lot of duplicates, the same guy, either an engine is kind of hitting the site repeatedly, or because the same user is hitting the site repeatedly, you see a lot of duplicates. So we need to clean it. So here's an example of what happens when you don't clean the data well. So here's the raw association data. If I were to build association like that, so the query is calculated. If I don't clean the data at all, I get things like fluke, Texas instrument, adding machine, pocket knife, TI-84 scientific calculator. And there's some junk here, like pocket knife. I don't know why pocket knife is related to calculator. I don't know why fluke is related to calculator. But once you remove deduped items, you remove the bots, etc., you actually get much nicer collections. So step number one, clean your data. Right? So you get Casio calculator, scientific calculator, HP calculator, TI calculator, and so on. So now we are talking, right? So now we know when the user says calculator what they might have in their mind, right? And one of the things we found in this data is time. I will go through all of the three examples, so I might have to skip some slides. Is that as I said before, all of our data is long tail, it's of long tail nature. So in some sense, what happens is about 90% of the traffic is covered by 10% of the queries, and the remaining 90% of the queries are covered by 15% of the traffic. If you look at the search results, it's exactly the opposite. So which means that average frequency of the search result site, the smaller search results don't come very often. The large number of search results happen quite often. But at the same time, where are query suggestions useful? Where do we get the most clicks? We get most clicks in the tail queries. This is a huge challenge for us. So in some sense, we get requests for query suggestions, or we get better click-throughs for query suggestions where we have very little data. So we're kind of working in a space where we don't have a lot of data, but we need to help the user because we don't have many examples of these things because of the nature of it. Right? So this is what we did was we started with 3 months of data, then we went to 6 months of data, and so on and so forth. And one thing we noticed as we launched this test on the site was as we went looked at more and more data because we were looking at tail queries, and so the query that was issued today maybe have been issued 2 years ago, and we can match them up, we get more information. So we have to see a lot more click-through as we get more and more data. So how much data do we look at in our nation? It's 2 years.
So for some of our projects, we're looking at 2 years worth of data.
2 years worth of query data, and that's, I'll give you the things like 4 billion queries, so it's kind of the order of power.
Do you also add some time factor?
What's that?
Age factor?
Yes, so we do aging the query data. So I'll give you another example of, actually this is right here. One thing you do see in commerce search is null search, which means you type in a query and you don't get into that. How often does it happen to you when you go to LinkedIn and type somebody's name and you don't find the person? You go to Netflix and type in a movie name and you don't find the movie. Or but the same thing, the movie is there. You go to Google and type in the movie name, it points you to the movie. Or you go to Amazon and type in a query name, product name, you don't find the product. eBay, same thing. So because of the nature of the commerce search engines, we do see a lot more, because the documents are much more structured and smaller, you do see a lot more empty searches and no results pages than you would see on Google, where they do these matching stuff. So one of the things you will see in most of these sites is when you type this query, which is borrowed, you will see a sponsored search, which is an advertisement, and the user says, well, these guys don't have it. I'll click on this, and so this is Google AdWords, and so the site gets paid from Google with the advertiser, so they monetize it some other way. Right? They sell a product, but at the same time pointing to somebody else and make money. Now, so there's a gray area between are you sure you don't have this in your inventory, or are you just getting out and then just not making money off of that? That's where the right. So I think I already said this. Here's an example of null searching the friction. So this person is coming looking for Fisher Price, bound CC, I think bound CC. And the first query types in is Fisher Price, bound CC thing. And it says, oh, maybe I didn't get anything. And he said, well, maybe I misspelled bound CCY. And you get anything. And it says, oh, I think I saw a butterfly when I was at my friend's house. So maybe I'll say Fisher Price, bound CC butterflies. Doesn't get anything. And he says, maybe I misspelled butterflies. So I think spell it some other way. And he says, oh, I think. So it should be for girls. So it says, Fisher Price, bound CC girls. Oh, come on, nothing. And it says, well, maybe I should just take off on the queries. The Fisher Price girls get 7 results. So it looks at the first page. Then it just backs off so much more. So this is huge, right? So there's huge friction here for the user. He would have dropped off at any point in time. And one of the things you do see that when you have null sessions or sessions with null results, the sessions are much longer. The number of search pages it goes through also goes to be much longer. So this is a huge friction on a site like ours. I think I'm going to skip over some of these things to why this might be happening. So one of this is there's a gap in the vocabulary. So for example, here's a boiler neutralization unit, and actually it is the same as condensate trap. So once the user has figured out that this query is actually this query, they find the results. So it might be because you're Canadian, you came looking for the Canadians call orange phones. It's really sensitive. They don't call them orange phones. So it's a different language, and it's not on the site. I gave this example before, novice versus power buyers, and just go over this. And basically, our conclusion is that null searches are really detrimental to the user purchases. So, and early nulls are much worse than later nulls because once a user has seen a bunch of stuff on the site, if they stick around, they're going to use and as I said before, they're ready to repeat, which makes it very, very hard for us to help the user recover. So, and they tend to be longer, and they also tend to be, you don't see very many examples. So this is a classic, it's a very good example of why we need to look at more data. And so one of the things we did is that here, there are some single term nulls like these, like model numbers and stuff like that. Once in a while you see double and triple term nulls, but most nulls are these long 4 or 5 term queries. So, but then you also can look at the categories from which these nulls occur. So, for example, Cinema Center Films per Month actually is an entertainment memorabilia category, or a classic Batmobile, the toys and hobbies category, and so on. So, one thing we do is that we refer back to the category. And another thing we understood was that a lot of nulls are related to brands. So these are, again, like as I said, the thoughts of the data. We go and look at the data from different dimensions, right? How long are the queries? How often do they occur? Or what kind of information do they have inside of them? Is there a brand name? And so to get things insight into the query, right? And are there any linguistic aspects in the queries? For example, you might have soup and sandwich snack set just by removing, and you might be able to get this. One of the things in eBay is that because there's a limited space in the title, sellers might drop these kind of conjunction words to save space. So when the user comes in and types in these queries with all of these, because the user thinks that they're giving more information to the search engine, but anybody who works in search knows that the more terms you type in, the less results you will get because it tries to use all the terms in the query, right? So, which is kind of interesting. Again, this is an example of misspellings. Sometimes you do see something like a spins cleanser, and the sponsored ad fixes it as typo for the correction for the user query. So this is the volume of data we looked at. So which is basically we looked at 1 billion queries and understood the semantic relations between them, and we looked at user behavior from over 4 billion items, which includes titles, products, titles, descriptions, and categories. And that's the scale of data that we mine to recover users from help our users recover from now. And I'm going to fast forward to the results because I'm running out of time. And then we built this experience, which is basically says, well, some of these null queries are related to maybe the user doesn't exactly know what they want, so maybe browsing the category helps. sometimes when you hit a null query, maybe it doesn't exist anymore, but at the same time, you can also recommend them things like, for people who search for this, also search for that, and that helps recover. Or sometimes we just build a recommendation out. Maybe you're interested in, because you type in that query, you might be interested in this product. So these are not exact matches like the search engine, but at the same time helps the users stay on site and be close to the theme that they input in their search query. Okay? And we could recover for over 50% of our non-searches by taking this approach. Is that a question? So, again, I'm going to skip over this, but because I already said that we looked at over a billion queries and 4 billion items. Now, I'm going to go to the second example now, so if you have any questions, please stop. Yes?
Do you track the user?
Yes?
I mean, last week I did one query.
What's
Today
that?
I come back.
Yes.
I do, suppose last week I searched for camera.
Yes.
This week when I come, do I get any suggestions on any new model?
Yes, so we have a recommendation system.
Okay.
I'm going to talk about that, but at the same time, we have pretty much everything. If you don't delete your cookies or if you're logged into the site, we have pretty much all the information about you, everything is logged. And that's the beauty of the system that we built in research. It can pretty much take as much data as you download it, and we can build models off of really, really nice. Yeah. Yes.
So you spoke about the recommendations that you provide with non-search.
Right.
Does that come from the same sort of engines that serve the search engines, or is that
Yes, it's a part of our search system.
Can you repeat the questions for the audience?
So the question was, the recommendations that happen for null search, does it come from the same search engine? So it is a part of our search engine. The architecture, Dinesh or Brian will be able to explain the architecture better. But it really, user comes in, there's a search box, you type in, and a whole bunch of things happen behind the scene. So the first set of things is, a bunch of results that match your query. But let's say if you don't find anything, a bunch of other things happen which go and tell you, hey, did you mean this? Or do you mean that? Or would you like to buy this? Etc. etc. So for the user, it's a single experience. It's as though they are searching in the search box and seeing these different experiences. Yeah. And same with the query suggestions. It's a part of the search. Yes.
Aren't you kind of competing with Google that has a different approach to, you put in a lot of terms, they give you any subset, and then they show you 400,000 things?
Mm-hmm. So, the question is, are we competing with Google? I think we are solving a different problem from them. So for us, we want to convert the user as quickly as possible. For them, they want to show good enough results, hopefully, because you're not paying for search, and, right? So it's free. For us, we want to match the buyer with the seller. So we want to mine as much data as possible to kind of try to understand your intent and point you to the product that you're interested in. Yes.
So relating to the Google part there, can you actually mine the methods that AdWords use for them, improving like you're doing in search queries?
That's the talk in itself, yeah. Yeah. Yes.
So with respect to tracked users, do you build explicit user models, or do you merely relate to the data relevant to that?
So it depends on the application. So for personalization, you might build user models, but sometimes we just aggregate a whole bunch of stuff. Sometimes you might take tail users versus head users. So it all depends upon the application. So we have a ton of those variations of that kind of stuff. Yes.
Do you clean the seller's data as well?
In
In the sense, like if they misspelled their words when they tag them?
So we have tools for the sellers, and I don't know if we provide similar help during listing time. For example, if you're a seller and you misspell Swarovski, I don't know if you provide the right spelling. We do that. Okay. So this it is possible, but we have tools for sellers which helps them pick the right kind of words in their title. Absolutely. In fact, to manage what a buyer might do.
Well, it doesn't matter now, right? I mean, what you showed is that it doesn't matter. They can go ahead and misspell it and...
They can go ahead, but let's say they misspell it the 65th way. Yeah. Then you have a problem. Yes?
How do you use cookies to match the sellers and buyers, Is there any cookie that you can use, or...
How do
you use cookies?
Yeah.
To match the buyers?
No, we don't match the buyers and the sellers from this thing. It's just a search engine. We just use a cookie as a proxy for the user. So if you are on the same machine, you left a cookie on, then you kind of sort of know it's the same person. That's the technology that most websites use. Any other questions? Yes.
How can you learn a new word? I mean, you have have 60 versions of the same word spelled differently.
Right.
How do you learn it?
The 61st version? Yeah, so we have to refresh our models. Yeah, we have to refresh our models every so often. So let's say, you know, we may not have it perfect, but we try to come as close as possible. A lot of these models have to be refreshed because people start misspelling, then you have to use it. And it's a fascinating talk where we want to know, for example, eBay, if you've been a long-term eBay user, you have a lot of acronyms. And I do not know whether the seller introduced acronym or the buyer introduced acronym, but there's an entire space of acronym languages that advanced buyers and sellers know. It's almost like a secret code language, and we don't know where it was born and how it is proclaimed. So in some sense, if you're a new buyer on the site, if you don't know the acronyms, for example, NIB or a new inbox is NIB. So a lot of sellers use the term NIB, and if you're a new buyer and you type in new inbox, you may not find those items. So it's our job as eBay to match these acronyms with those expansions. So some of these acronyms were created, and you find acronym dictionary. A lot of this is kind of just.
Is it manually edited?
No, it's not manually added. No, there is no site that you can go and get an entire dictionary, but we do.
Our users tell us, and I mean, Neel and Nish, these guys and Neel are all also kind of trending queries, but like when the iPad was introduced, it was the first time it showed up on eBay, it was a spelling mistake for iPod, right? It looked like a spelling, in fact, it was a spelling mistake for iPod for probably a couple of years, until all of a sudden one day it wasn't a spelling mistake. And it became not a spelling mistake actually probably well before it, probably from the day it was announced, right, before the product was available, because on eBay what you see is people start selling domain names right away. So as soon as Apple releases a product, 2 seconds later there's a gazillion domain names for sale on eBay that all start with that product name. And then it ramps up to the actual product launch. So our users just tell us.
Yeah.
How much is your search engine language agnostic or language aware?
How much is that? Well, languages we are on the search. I guess Nish is a better way to answer for that question. So all the techniques we have are fairly language agnostic. I mean, we've taken the same techniques and applied it to German, but at the same time there are some other things that we have to do to German because people can write words or combine words in some funky ways. But the nice thing about it is it's all in the user behavioral data. So let's say I break or I combine words in one way and she combines another way, and we have enough of me and her, we are good. We don't really have to understand German to do that because people are doing it for us. Right? When things happen at scale.
Yeah, so how do you handle Unicode? I mean, are these the internal dictionary Unicode or ASCII?
That's all those answers will come in. These guys can answer.
Yeah, we handle them.
Right, but I'm saying, is your base search term like it does Unicode characters, on that utility?
Yeah,
Base term is contained.
Yes, we have.
Oh.
Keep it in our dictionaries and our indexes.
So how much time do I have? Tell 2 more stories.
7 minutes.
7 minutes. Okay. 10 times as fast. Okay, here's a sort of example. So this is actually a fascinating example from economists. When I started the economics department about 3 years ago, maybe economists here before I start making jokes about economics. So if you look at all the economics papers, most of the economists have one data set, probably 200 rows of data. It's into a spreadsheet, and then they. John Levin was the Bates Clark Medal winner, actually was called. He led this research that I'm going to talk about, and he said, well, by the time he graduated, he knew every cell in the spreadsheet backwards. So that's how much he used to be. And then I interviewed one of his students who's working on this project. He said 450 million rows of data. You must be kidding. I mean, this is unbelievable for economists, right, to work with so much data. And this would be an example. I'll kind of try to rush through the story. Well, typically when economists talk about, when they're looking at, there are a ton of economics papers have been written on eBay by economists from outside. And typically what they do is that they want to understand, say, for example, the effect of shipping costs. What's the question about shipping costs? How much do buyers internalize shipping costs? What do they do? They go and buy 100 Pokemon cards, sell 50 one way, say they sell 50 another way, maybe 50 with free shipping and 50 with 199 shipping, and then they collect all the data and they see how they sell. They call it a field experiment, they massage it, they run regression, they do all that funny stuff, and then they come back and conclude that, well, buyers internalize maybe 85% of the shipping costs. So as we were gathering all of this data in the Mobius system, John said something very interesting. It looks like, if you're looking at it, it looks like your sellers are really the economists running the experiments. Because if you're a seller and you have thousands of these items to sell, what would you do? eBay is constantly changing its policies, and you're trying to figure out how am I going to improve my business, right? So we often found in this data that sellers are trying to figure out, should I sell this item by auction or by fixed price? What do I do? Do I sell some things by auction, some things by fixed price? Should I list it on a Wednesday or should I list it on a Friday? Should I list it at 11 a.m. or should I list it at 11 p.m.? Should I offer free shipping or should I charge for shipping? Should I use 4 photographs or should I use 8 photographs? And all of these questions they have, and pretty much any economic question that we had, there was hundreds of thousands of experiments that were sitting in the data that we were looking at. 3 years of data, over millions and millions of transactions, and we could do a really nice apple-to-apple comparison. Because these were items, in fact, we even put more and more constraints. Like, were these items listed at the same time? And then were listed exactly at the same time. So, and this was kind of pretty much any economist dream came true. And what we did was we took a whole bunch of economics papers that were written on eBay, things about how to buyers internalize shipping fees or auctions versus fixed price, and these were written over 4 years, and we could convert them up in half an hour. And the economists didn't even know they were using Hadoop for this because of our system. So very quickly, I'm going to give one example, which is, the question often comes, eBay is always charged for gallery images, and the question was, should gallery images be free, right? Should we charge more or less for gallery images? So we created an experiment, which is seller item category, and this is kind of a stack, what I call the economist in a box. So we built it on Mobius, which is, we get all the transaction data, and each experiment is basically identified to sell a category of this data. And then we have some sub-experiments like condition of duration, and stock price, etc. And then sometimes with dependent variables, we would kind of bucket them, and then normalize outcome dependent variable and try and fix effects regression. And I'm going to rush through this because we want to get the question of what is the effect of adding pictures on a view item page. It's not a great economics question, but at the same time, can we answer this question, right? Should eBay charges for extra pictures? Do they help? If you're a camera seller, should I pay extra for 5 pictures, or should I just not post enough pictures? That's a question often these are relevant questions for this. And what we found was a graph like this. Not very surprising, but at the same time, data told the story, right? So when you go from 0 to 1 picture, the probability of selling goes up significantly. When it goes from 1 to 2 to 3, up to about 5 pictures, we can actually, the chance of selling goes up. So it tells you that, and now it makes sense, right? Because 4 pictures is good enough information. If you want to look at the cost or the price at which they sell, what kind of premium do you get? Going from 1 to 2 pictures, you get a premium of 30%. But after about 4 or 5 pictures, it generally stays flat. So you can, so it basically comes back and says, well, the sellers, by adding more pictures, are likely to sell better, which means eBay can charge them because they can make more money, which is to educate them. On the other hand, you can say, let's give them away for free. That means they're going to make more money, which means in turn they will make more money, right? So we can ask a lot of questions like auctions versus fixed price, or should auctions charge 99 cents and so on. And we have constantly these promotions that we run. 99 cent auctions, list 50 items for free, etc., etc. And these are really important. Seller badging effect. If you're a top-rated seller, will I buy from you? Versus if you're not a top-rated seller. Or quite often you see that people list their items and say 10% of it goes to charity. Just because you say that 10% goes to charity, does it mean more people will come and bid on your items? Will they buy your items? And you do see there's a charity effect. In fact, we also see not only there's a charity effect, sometimes people fake it. When you have charity, when you actually list it for charity, we have to go through the eBay procedure for charity, but many times people don't, because people don't, actually it's not for charity, but in the description they say, I'm a true believing Christian, everything that I make goes to the church, please buy my item. And we do see clearly in the data such items do not sell very well. That's our bias understanding. So anyway, so again, it's a beautiful story of how economics can happen on big data. Now, how much time do I have?
2 minutes.
2 minutes. I'm going to tell a completely different story in 2 minutes. Okay, and this is how computer vision comes into eBay. How we can use computer vision technology to do research. So Wei Li, who's one of the vision researchers in my team, is there. There's a larger team back home. So,
Don't go
you
too
don't have-
fast. Don't go too fast. We're not rushing out the door.
Okay.
Yeah, it all depends on if eBay's gonna kick us out, so.
Brian Johnson wants to keep this. So, this, I can, if you guys can manage 10 more minutes, I'll try and close for this one. Again, I don't have to tell you that, there are more and more pictures, there are 6 billion photos uploaded monthly to Facebook, and that's through the 1 click a minute, which is how many pictures you have in Flickr. That's some interesting data I got from Big Photo Report. And there are over 90 million images on the web. So in some sense, 30% of it says 30% of that data on the web is images. So, and we're going to deal with more and more images than we're going to deal with text. So, and that we see in our data as well as our applications have gone. eBay's the GMV over the mobile phone was about $10 billion this year. So we are seeing a lot more transactions happening over mobile web or mobile applications. And this is an important platform for us. So this is one of the things that we were looking at. One of the challenges we undertook in research, we said, well, I'm looking at this room, there's somebody wearing a beautiful dress, I want to take a picture of it, I want something like that. Can you do that? Right? Can I be able to find? Will I be able to find such a product? So it's a shirt with a certain design, and I can go to the inventory, and can I find similar items to that shirt? It doesn't have to be exactly the same, but it has to be inspired by that. So green shirt, black shirt with some green and white, and can I find something sort of like that? If I'm going to a ball game of my favorite team, I just need to wear the right color, right? That's kind of the gist of this. So, what we again here we said that our computer vision team was fairly new, and one of the things, the challenges out of the gate was that we have to, it has to work really well because it has to work on eBay search engine at the scale that eBay works at. Our inventory is fairly diverse. We have got a large corpus of image data. The first set of algorithms we built had a training set of about 600,000 images. But I can tell you as we fast forward to today, that was a year and a half ago, we are looking at millions and millions of images to train the system. Okay? But at the same time, we have huge speed requirements in terms of performance as well. So we said, one thing we're going to do is in this project, we're not going to look at anything but images, which means that we're not going to take metadata from text and annotations, none of that stuff. We're going to push us as hard as possible to get information out of just pictures. Now let's see what the challenges we have. And deliberately can handcuff ourselves and say, can we do that? Right? So, and in fact, when we started first, we said even more, we will just look at colors and nothing else. So which means if I take a picture of your shirt, all I'm going to go for is the colors, not the patterns, and all that stuff. Can I find something that's similar to your shirt? Right? So, of course, you can always go from there to looking for dots and plurals and checkers or styles, all this stuff. But this was where we, and most of the rest of the talking, we'll just talk about, what do we do in the color space. So before we go to actually understand colors, we looked at text, and we said, what kind of information do we have about text? So you may not know this, eBay is the largest seller online of ties, neckties. And so we look at all, so what's largest seller of neckties? We look at all the necktie inventory and look at the text that was attached to the inventory, and we saw what kind of information is there. So this is a color pie chart, and this is a pattern pie chart. And one thing you see here is that about 50% of the ties did not specify, listings did not specify what color the tie was. The user put in the tie and expected the buyer to kind of take a look and understand what the color might be. Maybe they were kind of colors that the seller didn't know what color it was. And if you look at the patterns, about 48% of the listings did not have pattern information. So they had some obvious ones like florals and geometrics and paisleys and plaids, but they didn't know what to call them. So in some sense, actually, it's begging to look for, using computer vision technology to help our search engine. So unfortunately, we have those challenges because if you ever try to buy something on eBay, this is kind of images that you see on the site, right? So this is a kimono here that somebody's selling. This is somebody selling some kind of a white coat hanging on a white door. If you were to do any kind of vision algorithms on top of it, that's going to be quite a challenge. Here is a picture with kind of pretty lousy lighting. here I don't know if she's, this person is having the cat or the jacket, or something here. So, that's what kind of the pictures we get. We don't get nice curated kind of images. And this is the stuff that we have. This is really dirty data, right? So, so what does data tell you? So one thing we found that in this inventory, first is all summary statistics. So we had an inventory of 131,000 women's dresses, and we kind of cut it and say, hey, what are the different styles of dresses we have? So 3/4 sleeves and cap sleeves and half dresses and long sleeves and offshore. This gives us some signals on what kind of data distribution we're going to have. And then we did an average of RGB and average masking, and that gave us this information. So if you look carefully, it looks like, this is a Virgin Menu and cheap sandwich here, which is, it gives you the shape of the kind of the dresses. So for example, if it's long sleeve, it's going to have something like this. If it is in an outer, it's going to look like this, and so on. And it also tells you where the mask is, which is kind of more or less in the center. So this gives us the first signal as to how do we sample these images, right? And then we looked at the inventory. So if you take all the dresses and we just do a color distribution of this thing, what kind of dresses do we sell? What colors are most popular? We want to understand the space completely, right? So we find that most popular colors are red, orange, blue, and pinkish red. The not so popular color are green. So you see very, very few items in this space, and a lot more here, here, here. Right? Now then we want to look at the saturation. So if you knows HSV space or the colorfulness, and we see that a lot more lighter color are more popular than darker colors. But not that much of a strong signal as we see, but still you see a lot of lighter colors. And if you go to the space of max values for RGBs, you do see that there is a stronger bias towards darker colors than of the lighter colors, right? Then if you take a, I'm going to skip over this one because I'm going to come back here, come back to this slide. So if you're a written person or if you know about color science, you know that there are various ways of breaking down colors. Either you can break it down as HSV space or LUV space or YCBCR space or lab space. And each of these kind of give you a mix of red of the different colors, and we want to pick the right space, color space to do the search. And also, if you look at the dark, what does dark look like in each of these spaces? It looks this way here and looks different here and there. So which of these four should we pick? And that was the next question. We could pick simple RGB, or we could use HSV, or LGB, or so on and so forth. And then we need a patch. So which means we need a picture on the screen. So this is an actual listing. So this is a woman who's trying to sell a dress. It's hanging on a yard next to a tree, and we need to find the dress, right? So we need to get a patch from this to match the colors. So we found that center sampling really, really helps because most of the pictures are like this, which means that if we sample this region, we can get the actual color and the design of the dress. But once in a while, you find this where they show the front and the back of the dress, and if you do center sampling, what happens? All you're getting is the background. You don't get the actual picture. So by doing background subtraction, we know that there are two images, and we can do some magic there, right? So then we need to break down the color space, and we want to build this color space. So one thing we found that when you go to the lower saturation level, that is over here, there's a lot of confusion. So one thing we did that in the lower saturation space, we kind of bin these separately as gray, and then the rest of these HSVs were binned as into 8 uniform bins. So I'm going to skip over that. So now if you take this dress over here, what you see is that there are 4 spaces. One is a gray space, one is a H, S, and V. And we have these weights for each of these spaces, and then that's kind of along these 4 channels, as we do a linear combination using these weights to describe this dress. So it's basically 0.4 times hue, and 0.2 times saturation, and 0.4 times value, and 0.3 times gray. I hope these numbers are right. Does that look like right? Yes. Okay, that's fine. So we're using additive linear combination instead of multiplicative in a single channel because it helps us scale to a very, very large number. Okay. Now we also look at dominant colors. So for example, if you have a dress like this, then you want to know what's the most dominant color here, and if you plot this, and then we get that red is the most dominant color, right? So now we want to do matching. So we build an index. So for every dress or every picture we get, we create an HSV index based upon what I described. So when you get an input image or a query image, so I take a picture of a shirt, that is my query image. I take a patch from that, and I create the same HSV index of the top of that, and then I need to look up against the inventory. So how do I match? I basically do standard Hellinger distance, which is kind of this formula, and so this is kind of the architecture. So this is how we index, and this is how we match. But you know how such things work. You index everything in the color space, and you take the input query, and then you break it down into the same space, and you match against this using this distance function. And here are some results. We do precision at 2, 4, 6, and 8, and 10, and we try and use different distance functions, and we find that the linear distance function works the best. So we kind of went with that. And here are some example results. So again, this is just using colors. We don't use patterns, we don't use polka dots, we don't use the florals at all. And so this was the input query, which is kind of this plaid, or blue and red outer dress, and then whatever matches this are pretty good, very close. Here's another example of a plaid shirt, and here, because we're matching only colors, we find that this kind of this design. It's not a plaid shirt, but it's inspired by these colors. And the second one was a plaid shirt. The third one was a plaid one, but it has got this color mix and so on and so forth. But we do pretty well just with colors. We don't really do. So this was the first iteration of our system, and we launched it. But so if you go to eBay Fashion app, is it that? eBay Fashion, right?
eBay Fashion app.
Yeah, eBay Fashion app. So it's an app that can be downloaded. Actually, it works. If you go to YouTube, you will see videos of people using it. So you can also take pictures of people's clothes, or carpets, or wall hangings, and you can find matching stuff on eBay. You find money painting. You can find similar, inspired by money painting, kind of a combination of paintings on eBay or products on eBay. If you want to kind of decorate your living room, inspired by a certain color theme, you can use this app to do that. So it's a really cool app. It got a lot of press. Again, very simple algorithms, looking at a lot of data. And so now we have every image that comes into the site, it gets sucked into our index, and our algorithms come up with this index on a continuous basis. Of course, this is just the beginning of vision. I mean, our later algorithms use patterns and other stuff as well. We've gone into styles. For example, if you get a picture like this, so increasingly, one of the things we noticed that when we launched the app, most people were taking pictures of their faces. So so the first set of data was not really the shirt, but really the face and the shirt. And our algorithms were bombing because you were getting half of the face and half of the shirt. So to a person like this, you say, hey, what kind of dress is this? You might just say, oh, well, there's white polka dots in the back. Oh, you forgot the style. It's hard to say this about these styles. You forgot the lace. So we are getting challenged more and more to when you get a picture of a person. So the newer app, which is, I don't think it's released yet, it can actually identify your face and kind of tell you where to sample it from and extract information from there. So for example, we are also launching some really cool stuff like, it could be inspired by celebrities, where you could just say, hey, I want black pair of trousers, which or pair of jeans, and then we talk for a certain occasion, what should I buy? And you can think of all these various fantastic use cases. All of a sudden, computer science research looks really interesting. Right. So, we made a huge stride by just focusing on colors, but now we've started looking at other areas as well. And one of the things we are noticing is that data comes to our rescue. By looking at a lot of data, we can really run simple algorithms because we can confine the space into something that's really managed. With that, I'm going to close with a quote from Jim Bartel. It's great data, let's look at the data, we all have opinions, let's go with mine. So, any questions? Yes, still have patience. Yes.
So, do y'all use Python at all and SciPy or some other language and libraries to do the data processing for the images?
Those are hard questions. Ray will answer all those questions.
So for image processing, we type, you can use Python, MATLAB, that usually used by computer vision people.
Yeah, and with the SciPy library.
Right.
Thank you.
Yes.
Maybe two quick questions. Going way back to the original histograms, you're confident you're not seeing camera or lighting artifacts?
Oh, we do a lot of stuff. We do see the specular reflection. We do some. We have a lot. Yeah. So we have to do a lot of subtraction in terms
So
of.
there's cleaning.
Yes. Yeah. Cleaning. So that's a whole extra way that they said work on how to clean images. One thing is I'm the slides here, but a thorough understanding of the quality of images on eBay. It's fascinating. Just that focusing on that itself is much work. So now you can tell sellers how to upload better images. Or we can, if you upload bad images, we know how to subtract some of these effects and then get to the actual content of the image.
Do you use any of the image metadata, any of the access information? Like time
Can
of
you
day?
repeat the questions for the video as well?
Yes, so we use any of the image metadata. So yes and no, meaning the ones that I showed don't use, but at the same time, our system is aware of that. So for example, if you do pictures from a certain camera with a certain zoom and a certain whether the flash on or off, all of that information is used to improve. But at the same time, not in the examples I showed, that's metadata stored in the algorithm. So that we can correct appropriately. The back?
So is that a way to tell the user instant feedback saying that, hey, take a picture like this, when you see the image instantly,
Yes.
do some like initial...
Yeah, so the question is there a way to give instant feedback to the seller? So I don't know if there's a product yet, but we build prototypes where that's exactly what we do. One way is to upload better pictures, but at the same time, you don't always get that. Sometimes sellers bulk upload pictures, and you don't have any control over it. So we have to do it at both ends, while uploading time as well as uploading.
And could you also give like specific instructions that this part is not clear? Like,
Yes, you can do a lot of that stuff. Yeah, absolutely. We can tell you if you're uploading a dress, we can tell you exactly where to focus. There's a lot more information if you're getting better data. Yes.
So going back to your gallery example of 4 is the magic number.
It's not a 4 or 6. I mean, I kind of watered down a lot of stuff because for cameras it might be 6, for dresses it might be 8, and for iPhones it might be 2. So it all depends on the category. Yeah.
So did you look into the similarity of those pictures when you did the determination?
No, not in that study. So the question was, if I have 4 pictures for a listing, do I look at how similar these pictures are? Not in that study. That study is purely numbers. 1 picture, 2 pictures, 3, 4, 5, 6. So in some sense, I'm taking the picture of a car, so I'm selling a car. I think probably the good number would be 8 or 10, which we already know there's a separate study that has said that. Or some of the newer work that Ray is doing, they're looking at the quality of picture. So it's better to take 1 crappy picture than 4 crappy pictures, whereas it's better to take 4 good pictures than 1 good picture. So if you kind of combine, I mean that's a hypothesis. Hopefully it's true, but that's kind of the thing. So if you're taking bad pictures, might as well take fewer of those, and if you're taking good pictures, you want to take them. Yes.
So 90% of the work is actually in cleaning the data. What are the methods you use to clean the data?
What are the methods? So a lot of it. So for example, for the query work, what are the methods we use to clean the data? A big part of the work was looking at the bot detections. One big part of it. Deduplications, a lot of that stuff. Some of the upfront cleaning in terms of spelling and things like that we might do. Nish, if you want to talk a little more about what kind of cleaning we do.
Yes, mainly it's like understanding our data, so deduplicating, basically removing users who are outliers or weighting the data in such a way that some bad users don't make a lot of contribution to the algorithm. So if the algorithm is based on activity from users, you don't want to weight some users very highly, so that is one of the things. And also kind of really teasing out different data sets. Because there might be biases. What if someone is browsing using a web browser, that data is very different from someone browsing from a desktop. So how do we separate all these things when we build our models?
But a lot of it is manual then?
No, this is all automated, right? So we have data and we know what the platform is. So whether we should be using the platform as a signal in our algorithm. We know who the users are, how we should weight them in our algorithm. So it's all automatic, but the intuitions are coming from the complete. Right?
Okay. Yeah.
Is there any kind of domain modeling that you do or higher level
like raising like kind of for the intent of the user, whether they're trying to do a repair or something, or even just having an ontology of all different kinds of products.
So the question is, do we have an ontology? So we have an ontology of different products. Is that I didn't get that part, but so we have a category, giant category tree, which is about 15,000 nodes, and we have another project where we try and build this ontology of product or aspect relationship that you might use. So here we use the relationship between queries of a lot of it for query related work, and there's a lot of signals in the demand data itself. You don't really have to use the product. We can do it just with demand data. But yes. Yes.
You showed a number of all your vision examples were fashion. Mm-hmm. I'm wondering if you do any image analysis and matching in any other domain even.
So the question is, do we do anything beyond fashion? So for researchers to be heard, fashion is where we should go because it's just a normal thing and that's getting a lot of buzz. But the way we build our algorithms, we could just take it and say, for example, apply it to paintings or rugs or carpets. We could do a lot there. When it comes to shoes, we can still, it still kind of falls in the fashion space. But say when you go to cameras, it's a different set of problems. Colors are not that important. It's more related to kind of object recognition, shapes, and all kinds of stuff. So we have other stuff for that. But fashion is where you can tell a nice story and people will actually listen to it. Yes?
How do you handle discrepancies between what the picture shows and what the user might be listing? So sometimes they show like second-hand cell phones and they might have a lot of pink, but they show a black one because that's what people want. But you
well, we have those. So the question is, how do you handle discrepancies? Like they have a pink phone to sell, and then they're selling, putting a black picture.
Well, no, what I'm saying is they're trying to be deceptive. Let's say they have 100 phones to sell. Mm-hmm. Three are black, which everybody wants. Mm-hmm. 97 are pink. So they will show the right one, and you misindex.
Yeah. So when the question is when the seller has multiple quantities of the same product with in different colors. How do we do it? So we treat them separately. Sometimes we take them out. So all of the examples I showed, all this, even the product is built upon, that you have perfect item to image matching. You see that in iPhone covers a lot, right? So, for example, they have 50 colors of iPhone thing, and the most popular ones they never have. So those are out of the window. We don't use those things. Yeah. Yes.
One of the biggest problems that I know that online systems have with clothing or shoes and all that kind of stuff is size.
Yes.
So is big data helping in that area?
Yes, we've started working on that. I can't talk too much about. So the question is, how do we get size information? So the easy answer is there's textual data related to size. You can marry the image data and the text data, and you can get it. This is kind of the first kind of implementation that we did. But we're doing some new work in kind of matching size, and I can't talk too much about it. But the simple answer is yes. So for example, I like your shirt, but I want it in size 10. Is it available in size 10? So once I create the candidate set, I can go back and look at the text data or the aspect data to say, does it come in size 10? So I can do post-processing to filter out those things. Yeah. But at the same time, if I have to figure out what size it is, that's a different challenge. And that goes into the space of augmented reality. Okay.
I think going way back, one of the on the list of topics, I guess potential research topics, you mentioned MDM, and I'm just wondering what interests.
What is
eBay has to do with clicks that don't come from events that don't come from clicks.
Oh, member to so MTM, when I say it's member-to-member messaging, actually Brian is right behind you. This other Brian, so it's text mining when you have, so very few people have access to this data, it's private data, but at the same time there's a lot of information.
Okay, I misread it as machine to machine.
Oh, sorry. Well, that's a different topic.
I think about it as the sort of internal eBay email system between buyers and sellers.
Yeah. So that is text mining of private data. Yes.
Okay, have you been able to provide some information from the data mining for the sellers to improve their conversion?
So the question is, have you provided any data tools to the sellers to get the things? So we have a lot of tools on the lab side as well as through the seller. I forget what this called.
Not just tools, but any specific information not just the opinion.
No, not even.
Supposedly I live this the product.
Yeah, so
how, what do I should?
Yes, so we have a lot of assistive tools. For example, what kind of titles to use, what quality of pictures to use, what kind of shipping charges, how much do I charge for shipping, right? The biggest problem, especially in the used goods market, is I don't know. I'm selling this humidifier, and I don't know what to charge for shipping. Should I charge $10? Should I charge $50? So in some sense, so there's another project which actually there's a tool also on the lab side which helps you, which will tell you, if you're selling a humidifier, this is what you might want to charge. So it tells you upfront how much to charge, because these are all the huge friction points we see. What category to list in, what kind of title to use, what kind of pictures to take, should I list this option or fixed price, how much should I charge for shipping, and we have tools for assisting for all of those.
Is there much analytic support for people that want to develop apps, like for sellers? So there's a lot of data you can't get at, and so you can't really do some of the retail analysis to give advice to sellers.
So we have. So the question was, do we have analytics tools for sellers?
Well, I mean, I understood that there was apps that could be plugged in to eBay that sellers could use, kind of like retail supply chain type of things.
Right.
And so I've worked in retail supply chain in the past, and it's analyzing a lot of data, but it seems in this case, there wouldn't be much data that you could get as a third-party developer.
Right. I don't know. Does anybody from eBay want to answer that question? Right?
We send a lot of data to a third party that resells, but I'm trying to remember their name right now.
That's
Therapy.
It's a Canadian company which resells data in some form, which third parties use to provide.
Exactly. Yeah, exactly. It's not private. It's not personal data. It's aggregated data.
It's aggregated data. Yeah.
The best people for data are channel advisor, because people have their own stores, they sell through eBay and they sell through Amazon. So channel advisor, they get everything.
Multi-home people.
They write some really nice blog posts sometimes.
Okay, Paul.
Can you talk about how eBay does recommendation? You use matrix factorization methods?
Yeah, that's a separate talk. It might be back. But we can talk about it. Yeah, so we have a bunch of other programs. eBay's recommendation system is actually probably a couple of papers in that as well. But eBay's recommendation system is a little different from what Amazon has, as you can imagine, because we don't have products. So we work in this large sparse space of item to item, right? So your cell phone is different from mine, and we're trying to keep it as unique as possible, and so on. So pretty much any entry in matrix is fairly sparse, because if you use some other completely not related to matrix factorization techniques to kind of do some filtering. There are a couple of very good papers that we wrote, which actually were implemented on the site as well. And another thing about our recommender system, so we look at similar and related, which are also substitutes and complements. So when buyers are participating in auctions, quite often when they come to the site, they lost an auction. You really don't want to recommend a complement, you want to recommend a substitute. So finding items exactly similar to the ones that they may have lost. So that's a big part of our recommendation system. And the other part is we bought a TV and sell a TV stand with it, which is kind of Amazon kind of complement. So yeah, so we have both of those. Any other questions?
Where are these locations of the open source document?
Open source, so OpenMobis is GitHub, right?
It's on GitHub.
Okay, yeah. Okay, more questions? Okay, great, thank you.